Hello and welcome back to the Architectury Multiplatform Modding in Minecraft series. And today I'm going to show you how you can create a block that has a custom menu and custom functionality that is not present in the vanilla game. In our case, for this tutorial, I'll be implementing and showing you how you can do a block that can store water. So you can put in a filled water bucket and then the bucket gets emptied and the block stores the water, and then we can put in an empty bucket and get a water bucket back out. And to speed things up a little bit, I've already prepared everything that we've already done in the previous episode. More specifically, everything related to the Ruby crate is essentially what this block is based on. So I've created a GUI block here. Everything in here is identical to the Ruby crate block, other than obviously we use a different block entity and a different ticker down here. Then I've also created a block entity, and this is also, as you can see if I open the crate real quick, identical in content. The only difference is that I've limited the inventory size to 2 slots instead of the 27 we had for our Ruby crate entity, and I didn't populate the create menu method yet. Right now we're returning null here. We'll change that once we've implemented a custom menu. And we will also need to implement a tick method down here, which I've not done yet because that's something new I'm going to show you today. And both the block and the block entity are fully registered with the game, and the item is also registered for the block. And obviously all the resources like block states, textures, models, etc. I've already shown multiple times, so I'm not going to show those again. It's a simple block from that perspective. The only thing that is new is that I've added in our textures folder here a GUI folder, and there this GUI block PNG. This is what the menu will look like. So we have 2 slots here, one for putting in filled water buckets, one for getting out water buckets then if we put in an empty bucket here, and then obviously the player inventory down here, as with every other block. This is a base texture. We will also add a custom text later on top of this texture. I will show you that when we get to it. But other than that, everything else I've already prepared. Just look back at the recreate videos and everything is explained in there, how to add this block and everything related to that. So what we need now first is we need to populate this create menu method down here. And for this, we're going to create a new package inside of our mod main package and call it UI to hold all of your UI related classes. And in here we are now going to create 3 classes. The first one is for a menu. I call it GUI block menu. Then we need a class for the screen. I'll explain what the difference is in a bit. GUI block screen. And then we need a class that holds a menu definitions. So our tutorial mod menu types class. And the first thing we want to do is to write our menu. Now, before I begin showing you how we implement this, I want to quickly talk about the difference between menus and screens. Because menu essentially exists twice, once on the server and once on the client, while the screen only exists on the client. So the menu is essentially the underlying architecture of what you see on screen. The menu dictates where the slots are located and how those slots interact with your player inventory and how those slots interact with, for example, hoppers or stuff like that. And the screen is simply that what is rendered on your screen. So if you imagine the screen being completely blank, you would still have the slots on screen, although you could not see them, but you could still add items in there, and those items would still be visible on your screen. Just there would be no background behind it, and you would essentially see nothing. So that's the reason why the menu will be a bit more complicated, because we need to differentiate between 2 versions of the same menu, once on the server side and once on the client side. And the first thing we need inside of a menu is we want to extend the abstract container menu. Abstract container menu. The abstract container menu provides most of the stack and inventory interaction things that we need, so we don't need to implement a lot. Now we need to implement 2 methods, the quick move stack and the still valid method. We'll implement those in a bit, but then it's also complaining that there is no constructor, and this is the first thing we're going to fix, because actually we need two constructors. First, we create a new GUI block menu constructor, and in here we take an integer for our container ID, and we take an inventory player inventory. This is the first constructor we want, and this is the client-side constructor. So this constructor will be used if the menu is created from the client side. And then we also need a constructor for the server side of our GUI menu, and this is a public GUI block menu. And here we want to have first again the container ID, then the player inventory, but now two additional parameters. First we want a container, and we want a container data. Now the container is the server-side representation of the container, in our case the block entity, because this is a container block entity, so it is a container, and a container data object, and with that we can sync data from a block entity to the client, because the client obviously can't access the block entity because that is on the server side. So we need a middle layer that can transfer the data we want to the client so that we can render it in the screen later. And this is done with the container data object. Now in our client-side constructor up here, we want to call the other constructor, and we want to pass for the container a new simple container with two slots, because as we've said in our block entity, we have an inventory size of 2, so we need a container with 2 slots. And for our container data, we pass a new simple container data with 1 slot. And then we need to implement our server-side constructor down here, and for this we first call our super constructor. And in here the first parameter I'm going to leave empty for now, because that will be our mod menu type, and we haven't registered a menu type yet, so I'll leave that empty, and then we need to put in our container ID. Now the next few lines I'm going to copy real quick, and the first one here, container data is this, for 1. And the first one here, check container size, ensures that the container we put in here actually has at least 2 slots, just to prevent errors from happening later. And we need to ensure that our container data has at least 1 entry in it. Next, we want to store our container and our container data inside of this class. So we are going to create 2 variables up here, a final container and a final container data. And these 2 variables we want to populate, so this container is container and this data is container data. Now next we need to add the slots to this menu, because the game needs to know where the slots on the screen are located, so that if you hover with a mouse over a slot, the game knows which slot this is. And for this I'm going to copy over the slot adding part, and I'm going to explain this now. So the first thing we add here is the player inventory. So if we go back to our texture, this is these 27 slots here. This is the player inventory, and we have 3 rows. This is the first loop, the second loop, 9 columns in each row, and then for each of those positions we add a new slot. We link the slot to the player inventory. We give it a slot ID, in our case the column plus the row times 9, and then we add 9, because if we go back to this texture, the numbering of vanilla would start with this is the 0th slot, the first slot, second, third, etc. So this would be the 9th slot. So we need to start with the 9th slot, and since j and I are both 0 at this point for the first slot, we need to add 9 so that we get the 9 for this. And then we need to put in the x and y position of the slot. Those values here are just from the regular chest, because this texture has the same proportions as a regular chest texture. So if you would have a texture that has a different layout or a different size, you may need to experiment with those values a bit. But essentially this X, we start 8 pixels from the left. So we go 8 pixels in, and then each slot in the vanilla Minecraft resource pack has exactly 18 pixels in both dimensions. So we add the column we're in times 18. To get the number of pixels, we need to go to the right, and then we start 48 from the top, and then the same 18 pixels in height per slot. So this is 48 pixels and then 18 pixels per slot. And the next thing we do here is we do the same for the player hotbar. Here we start with 0 for the slot and go up to 8. And here again 8 from the side, and then all of the hotbar slots are at the Y level of 142. So this is always 142 on this line. Again, if your texture has the slots in a different position, you need to change these values here. And last but not least, we add our own slots. So those are the 2 slots in the top here, and those are the slot 0 and slot 1 of our container. The container again is this entity, and we have 2 slots here, so slot 0 and slot 1, and those positions again here correspond to those 2 slots. And you need to obviously figure out these positions from the texture you use for your menu. Or for your screen later, because the menu obviously doesn't have the texture that's coming from the corresponding screen. Finally, what we also want is we want to add our data slots. So we call this dot add data slots and put in here our container data. And this then syncs the container data to the client so that we can later access the data we have in here from our screen. That's everything we need to do for the constructor. Now we need to implement the quick move stack and still valid method. For the still valid method, this is pretty simple. We just can call container.stillValid and pass through the player. This will do everything we want to do here. And for the quick move stack, this is a little bit more complicated. So I'm again copying over the content for this method. Now what we do here is first we define a new item stack. And this is the stack that is the result of the move action. So the stack that is actually moved. For example, if you shift click on this slot, all contents of this slot would move down to the inventory if that is possible. So this stack would then represent the items that move down here. We first define it as an empty stack because we still don't know if there actually is any room, if we can move the stack, etc. And then we get the slot that the player has clicked. So this slot can both be from our own container or from the player inventory. And for this, we later need to differentiate and find out what slot this is exactly. But first, we want to check if the slot actually has an item, because otherwise there is nothing to move, so we can just return our empty stack. But if we have an item, we get those original item stack from the slot, and we also assign the copy of that to a new stack, so that we can then modify our original stack without modifying the new stack. So the first thing we do here is we check if our index is less than 36. Because the player inventory plus hotbar down here, these are 36 slots. So if we have a slot that is less than 36, this corresponds to those slots down here. And in this case, if we are inside of our player inventory, we want to move an item stack, and this is our original stack, into slots from 36 to 36 plus 2. So this is the range, inclusive and exclusive. So this is why we have this plus 2 here. This is the range of our own container, so those 2 slots in the top. We don't want to reverse the direction. And if we can move the stack, then we just return an empty stack because we have not moved anything. If, on the other hand, the index is less than 36 plus 2, so because we have an else if here, we know it is at least 36, and we know it's less than 36 plus 2, so it is one of our 2 slots in the top here. And in this case, we want to move our original stack to a slot from 0 to 36, so to any slot in our player inventory down here. And again, if we can do that, we return an empty stack. If we have a slot that is not inside of any slot that is valid for our GUI, we just return an error and say we can't move anything. And finally, we check down here if now our original stack is empty, because it could obviously be the case that we can't move the entire stack. So if, for example, we only have space for 32 stone in our inventory and we decide to try to move a full stack of stone, we obviously can only move 32. So in this case, our original stack would not be empty. But if it is empty, we want to make sure that the slot actually is set to an empty stack. So we set the slot to have an empty item stack in it. Otherwise, we just say that the slot has a changed amount in it, and that indicates to the client then that it needs to update the rendering. And finally, we say on take onto the slot, and that means that the player has moved an item from the slot, in this case the original stack. And last but not least, we return the new stack. And that is everything we need to do for our menu. And now we want to register our menu. And for this, we're going to our tutorial mod menu types class. And the first thing, similar to every time we try to register something, we need a registry supplier and a deferred register. Let me just copy that in. So we need a deferred register for menu type of question mark. And this is obviously on the menu registries. And then we create a registry supplier for menu type of our GUI block menu, the class we just created. And then we want to have a public static void init menu types. And we also want a helper method for the registration. So this is a little bit more complicated than for blocks, for example, because we have a public static and then we define that the parameter t extends menu type of question mark. And then we have a registry supplier of t, register menu type, with the name of the menu and a supplier of t for our menu type. And then we just call menu types.register with a resource location and our menu type supplier. And then we can actually register our menu type inside of this method. So we call register menu type. Then we use GUI block as the menu ID. And then we provide with the supplier here a new menu type, pass in the constructor in this function notation in the front, and feature flag set.off. We don't have any feature flags set for our menu, so we just provide an empty feature flag set here. And this references the client-side constructor. The server-side constructor we will later call from our block entity when we get to that. Now that we've registered the menu type, we can go back to our menu and populate the first parameter here. So we can go in here and say tutorial mod menu types.GUI-block.get. And with that, we have implemented our menu. And now let's actually make sure that we can open our menu when we click on the block entity. So we go to our block entity and we want to open our menu. So we go to the create menu method here and just return a new GUI block menu. And now we can pass in the container ID, we can pass in the inventory, but now we also want, as I said, we are here on the server side, the container and the container data. The container is simple, we can just put in this, but now we need the container data. And for the container data, we are actually going to the top and implement now the functionality that this block should later have. So let's start by saving a private int here for the stored buckets, because we obviously need to store how many buckets of water we've stored inside of our block. And we set it to 0 as the default value. And then we need a container data. So below items, we're going to create a private container data and call it data. Then we need to populate this data field. So in our constructor, we call this.data equals new container data. And in here, we now need to provide a few methods. Now, the first one is the get count at the bottom here. This simply returns how many data entries are handled by this container data. In our case, just one, because we just have one value. And this is also the size we need to specify here and here, 1. And then we have the get for our index. And in this case, I want to make sure that if the index is 0, we can return our stored buckets. Otherwise, we just return, let's say, -1. And then for set, in a similar way, we want to check if the index is 0, and in this case, we want to set stored buckets to the value we get as a parameter here. And that's everything for the container data. And this we then can pass down here in our constructor for the menu, this.data. Now we also want to have some functionality that modifies the stored bucket amount, and this functionality we're going to implement in the tick method down here. And I've already prepared that, so I'm just going to copy that over. Now, the first thing we're doing here is we check if the block entity this tick is called for is actually a GUI block entity. And if it is, we get the item stack in the first slot. And here again, we get the item 0 because the 0th slot of the block entity container we have here is the first one in the GUI. And this is the slot we want to put a full water bucket in so that it gets emptied. And this is the reason why we check if the item stack here is items.water_bucket. And if that is the case, we check if the stored bucket count of our GUI block entity is less than 64, because that's the limit I chose for the number of buckets we can store inside of this block entity. Obviously, if you want to have an unlimited block entity, you simply don't need to specify a limit here. And if we are less than 64 buckets here, we increase the number of stored buckets, and we replace the item in slot 0 with a new item stack of a regular empty bucket. So that means our bucket gets emptied. And after that, we also check the second slot. We get the second slot item stack here with get item of slot 1. And if we have an empty bucket here, we do the same thing essentially in reverse. If we have more than one stored bucket, we decrease the number of stored buckets and replace the item in slot 1 with a filled water bucket. And that's essentially the entire functionality of this block. And this ticker again is added through the GUI block and this get ticker method, but that's something I've already shown you in regards to the furnace and the Ruby crate in the past. And with that, we are essentially finished with all the functionality of our block. The only thing that's missing now is that we can't see anything yet because we don't have a screen for this block yet. And this is the last thing we want to do now. And for this, we want to implement a GUI block screen class. Now, the screen class extends an abstract container screen because we have an abstract container menu as the base for our GUI block menu here. We want an abstract container screen for our GUI block menu. And again, we want to implement a method, and the only relevant method we need is the renderBG method. So let's implement that. And we also need a constructor in this class, so we create a constructor matching super, and this we can just leave it as it is. This is fine for what we want to do. Now the first thing we want to define in here is the resource location of our background texture. And for this, we just define a resource location from namespace and path for our mod ID and put in the path for this PNG texture here. So in our case, our textures folder, GUI _block, and then the GUI _block.png file. And then we want to render this texture with the renderBG method. Now, what we need is the following: render system.set shader color, and then 4 times 1. That means that we essentially don't shift anything of the color, because that is just use the color as it is in the texture. Then we want to set the shader texture for the texture index 0, the background texture we defined up here. Then, just to help us, we define the X and Y position of our image, and those two are the positions on the screen. So 0, 0 is the top left corner of the game screen. And since a GUI texture obviously doesn't fill the whole screen, we take the width of the screen minus the image width, and the same with the height and the image height, and divide those by 2 so that we can get the correct position for the top left corner of this texture to be rendered on screen. And then to render this texture, actually, we just call on this GUI graphics object we get provided here, the blit method, and use the render type GUI textured. With our background texture, provide the XY coordinates. We don't want to have an offset, so 0, 0 here. The image width and image height, and then the texture width and texture height. And the texture width and texture height, and as you can see, we have a 256 by 256 PNG file. This image isn't 256 by 256 pixels. This is actually a little bit smaller than the whole file. And those are coming through the image width and image height. And those values are defined here inside of the abstract container screen class. So you need to override those if your image, your visible image, is larger than the one of a regular chest, because this is the same size as a regular chest. So if you, for example, use a double chest sized screen, you obviously need to override this image width and this image height parameters here inside of your constructor to match the visible area of your texture here. Now, an important note I want to mention here is that this only works that way from 1.21.2 and newer, because in the previous versions, 1.21.1 and older, you need something slightly different. The majority is identical, but you also need, and I'm putting this in as a comment here, just so that you can see those lines if you check out the source code on GitHub, for example. Let me also copy over this marking here. This line you would need additionally in 1.21.1, render system.set shader, game renderer, and then get position text shader. And this is essentially no longer necessary in the newer versions. This has been replaced by this render type GUI textured in the front. And this is the reason why you also need, instead of this line we have down here, so let me mark this also real quickly, I need to and later. And that's why you would need, instead of this GUI graphics.blit with these parameters in 1.21.2 and later, in 1.21.1 and earlier, you would need GeoGraphics.blit, and then just with the background, X, Y, the offset, image width and image height. The texture width and texture height were optional parameters, so you could also add them in this method, but since 1.21.2, they are required, so we need to specify them here. But if you're working with 1.21.1, you need this method down here, this call instead of this one, and you need to also add this one. All the other calls are identical. That hasn't changed. But we're not done yet with the screen, because we also want to render some additional things. As I said earlier, we want to render a text that shows us how many buckets of water we've actually stored inside of our block. And for this, we want to also override the render method. The regular render method with the GeoGraphics mouse X, mouse Y, and the partial tick float. And the first thing we want to call the super render method. And next, we want to call the render tooltip method. And the reason we want to call the render tooltip method is because, if you know, in Minecraft, if you have a menu open and hover over an item, you see, for example, this pop-up with the item name on it. And this is not rendered by default. To render those item names and additional information as a tooltip, as the name suggests, you need to call the render tooltip method. Next, we want to also render a text and show how many buckets of water we've stored. And for this, I'm quickly going to define the Y position of the text. And we define that by height minus image height, divide that by 2, and then we add 24 to that. I've figured out that in testing that this is a location where the text doesn't obstruct anything else. But again, the exact coordinates of the text you want to display, you need to figure them out matching your desired behavior and your desired look of the menu. This is just for demonstration purposes. And to actually draw the text on the screen, we call GUI graphics.draw centered string. You could also use draw string or draw string with backdrop. Just choose the method that matches what you want to do. If you have a multi-line string, so you want to have multiple lines, you can also use the draw word wrap method down here and provide a formatted text here. That can also contain line breaks, etc. So if you want to draw longer texts, use the draw word wrap method, but we just want to draw a centered string. And the first thing we need to provide is the font. So we just use the default font that is provided by the container screen class. Then we want to provide the string. In our case, I'm just going to put in a regular string, stored water, stored water, and then put in the amount of water. For this, I'm just putting 0 right now. We'll change that in a bit. Then we need to provide the x coordinate. I just want centered, so width divided by 2. We want to provide the y coordinate. And the color of the text, I'm just going to go with a black text, so all zeros for the black color. Now, to get actually the water level we have, we go this dot menu, and then we can access our data, and then we can get the 0th entry. And as you recall from our block entity, the index 0 corresponds to our stored buckets. And with that, we have our stored buckets. And that is everything we need inside of our GUI block screen. And that's everything we need to do to render this. But as you can see, we haven't called the constructor anywhere yet, and that is because this screen is not registered at any point. And we obviously need to link this screen with our menu so that the game knows if the client should open this menu, it should use this screen to render it. And for this, we need to go to our menu types and do something a little bit more interesting here, because Architectury provides us with a method to link those two together. And the important thing is we just want to do this on the client side, because the server can't render a screen because it has no renderer. And for this, we use the client lifecycle event dot client start client lifecycle event dot client started dot register, and then we get this lambda notation here, and inside here we can now execute code that is just run on the client side. And in Architecture's case, we can use the menu registry dot register screen factory. We need to provide our menu type here. This is our GUI underscore block dot get, and we need to provide a screen factory. In our case, this is simply the constructor for our GUI block screen. But an important note I have to add here is that in testing, for me at least, this only worked with Fabric. I believe that has to do that I'm using a beta version of NeoForge in this project. So this should work if you're using the most recent versions. But if you have the same issue as me, where this only works with Fabric, I will also show you now how you can fix this in a not very pretty but functional solution. And for this, we want to use an if platform.isFabric around this client lifecycle events call here, so that this is only executed if we are inside of a Fabric mod loader environment. And while we're here, I'm also forgot to init the menu types earlier, so we also want to head to our mod main class and call this registration method for the menu types. So tutorial mod menu types dot init menu types. But we now want to register the screen for our menu in NeoForge, and for this we can go to our NeoForge main file, and in here we then can create a client event bus subscriber for our mod. For this we create a public static class client mod events, and we tag this with an add event bus subscriber for our mod ID tutorial mod mod event bus, and then we need to provide the value equals dist.client, so that this corresponds to the client mod events. And then here we then can use add subscribe event for a public static void register screens with a register menu screens event. And in here we then can call event dot register, and here again we can pass our menu type tutorial mod menu types dot GUI block dot get and our GUI block screen new, and that fixes the issue, for me at least, for NeoForge. So if you come across the same issue that just using the Architectury client lifecycle event here with the menu registry doesn't work for Neo4j, you can use this method to make it work. And if I haven't forgot anything, that is everything we need to do for our block and our custom menus. So let's start the game and see if that worked. And with that, welcome to the game. This is here, in this case, the Neo4j instance. As you can see, we have a GUI block. We can place it down, and if we now right click on this block, you can see we have our GUI block, we have our text stored water 0, and we have our 2 slots up here. As you can see, the game recognizes in them if I hover over them. The game also recognizes all the other slots. You can see we have the tooltips. And if we now take a water bucket and place it in the left slot, you see the water bucket becomes empty and we say store water 1. We can then walk away with an empty bucket, come back later with another water bucket, store it also, and now we have 2 stored water buckets. We can again walk around, come back, and now we can place an empty bucket in the right slot and it gets filled up and we have 1 stored water. We can also do that again and now we have 0 stored water. And if we take another bucket, you can see it doesn't fill up because we don't have any more stored water. If we now put a water bucket here, you can just see the water transfers over to the other bucket. So our block with the menu works in Neo4j. Let's also check Fabric just to be sure that it worked there as well. And with that, welcome to Fabric. Let's open our menu, and as you can see, it looks the same as with Neo4j. We can put in a water bucket, we can put in another water bucket, we can pull our water back out, and it obviously doesn't let us extract more water than we put in. So with that, you now know how you can create such a custom GUI, a custom menu for your blocks. You know what the difference is between menus and screens. You know how to register and link them. Thanks for watching. Goodbye.